So we've looked so far at solving quadratic equations using factoring and the zero product property. Sometimes there's a shortcut you can take. You don't have to factor, or indeed you might not be able to factor. And in some special cases, what we use is called the square root property, often written as sqrt or squirt. When you use computer technologies and you want to input square root into a formula, often the shorthand for square root is sqrt, squirt. So the square root property, this stands for, or squirt, stands for square root property. Well, squirt stands for square root, property stands for property. All right, that's enough of that. So what does the square root property, when does the square root property work? Well, first, we're still talking about quadratic equations. So you're still going to have something going on like ax squared. You're going to have some term with a coefficient and a variable configuration of x squared in it. In fact, this is going to be the largest degree term in the polynomial. So you have ax squared equals some number c, some actual number. Notice that in this situation, there's no linear term. There's no term x to the first power. So when you have a polynomial that the only variable configuration visible is the x squared, then you can use the square root property. So just to be clear what I'm talking about with no linear term, if I have ax squared plus bx plus c equals 0. In this case, the c has just been moved over, right? I moved the c onto the left-hand side. If there's no middle term, no bx term, then you can solve the quadratic using the square root property. And it has a little bit of a trick to remember, but it's a straightforward calculation. So if I were to calculate this or solve this, I would first want to divide out the a, because remember, we're trying to get the variable alone. That's what it means to solve an equation. So I'm going to divide through by a, so I'd get x squared equals c over a. And remember, c is just a number, a is just a number, and by number I mean a numeral, what we're used to working with before we ever entered algebra at all. So I'm going to call that d. I'm just going to give it a numeric value so I don't have to keep writing the fraction. So x squared then equals d. Now, what I want to do to get rid of the square on the left-hand side is I'm going to take the square root of both sides. So that's easy enough, right? I'm allowed to take the square root of the left-hand side as long as I also take the square root of the right-hand side. And so that would give me x equals whatever the square root of d is. Okay? Straightforward, super duper easy calculations, nothing really new, nothing to have to learn, nothing to have to develop. But there is a rule that you have to remember, and the rule goes right here. So before I tell you the rule, I'm going to show you why the rule exists. Let's go back up here to this part of the example, and I'm going to write out an actual example with numbers so it's easier to see. So say you have 3x squared equals 27. So that would be in this form. If I were going to write this same thing in this form, it might look like 3x squared minus 27 equals 0. Add 27 to both sides. I get 3x squared equals 27. Now I'm going to divide both sides by 3, so I get x squared equals 9. Now I want to take the square root of both sides. Not such a big deal at this stage of the game, right? So square root and the square root. That tells me, find my color here, that tells me that I'm looking at, well, the square root of x squared is just x, and the square root of 9 is 3. Seems like everything is hunky-dory at this stage of the game, but it's not. There's a little hidden problem here. And that hidden problem is I'm looking for numbers that when I square them, I get 9. So easily enough, 3 times 3, 3 squared, not cubed, 3 squared equals 3 times 3, which equals 9. What's the problem? I got exactly the right answer. X equals 3 fits that equation. But watch this. Negative 3 squared, which is negative 3 times negative 3, also equals 9. Two negatives makes a positive. 3 times 3 is 9. We have this second solution to this equation. Two numbers make this sentence true. One of them is positive 3 and one of them is a negative 3. So in a quadratic, when you're solving a quadratic using the square root property, we have to make use of or remember that in this case, when I take the square root of both sides, I'm actually creating a situation where there are two answers, not one answer, or two solutions, not one solution. And so for the square root property, this little spot right here, what we're going to write is plus or minus the square root of d. So we'll say x equals plus or minus the square root of d. That gives us the situation or the opportunity to take positive square root of d and negative square root of d, and it gives us both solutions. So let's do some examples for this. I think the examples will make it abundantly clear what we're doing. Okay, so let's do c squared minus 25 equals 0. Let's make that prettier. Okay, so you should immediately see, and I'm hoping by now you do immediately see, that this is really a mother's face problem. I could write it as c minus 5 times c plus 5 equals 0. And then when I use the zero product property, I get c minus 5 equals 0 and c plus 5 equals 0. So c equals 5 and c equals negative 5. So we're expecting two answers. But we want to do this using the square root property, because the cool thing about working in algebra is it doesn't matter which property you use, you have to get to the same solution. Otherwise, all of algebra falls apart and we all get to go home and never come to school again. And before you get your hopes up, that's not going to happen because algebra doesn't fall apart. So let's look. I'm going to do it in a different color just to make the point. I'm going to write it again. So c squared minus 25 equals 0. We know there are two answers, two solutions to this. Let's find it using the square root property. So that would be c squared equals positive 25. Take the square root of both sides, and I get c equals plus or minus, don't forget that part, plus or minus the square root of 25, which is 5. And look at that. That says c equals positive 5, that's this one, and c equals negative 5, that's this one. Two solutions to the same equation. If you have a square, if your highest degree in the polynomial is a square, then you're going to get up to two solutions. You may not get two, you may only get one, you may get none, but two is the most you can have, so you have to try to find them all. And in this case, I found two, I'm done. There are no more solutions. So I know what happens sometimes when I tell you that there are two solutions to the same problem, is you start thinking, well, maybe there's a third one, maybe there's a fourth one, maybe there's a fifth one. Luckily, algebra has built in a wall for us. The most solutions we can ever find for a quadratic is two. If you only find one, you want to try to find more, but the most you can find is two. In this case, I have two, so I know I'm done. Let's do another example. Let's take 5w squared plus 12 equals negative 8. So the first thing I want to do is isolate the variable in its squared form. So I'm going to subtract 12 from both sides. So I get 5w squared, negative 8 minus 12, right? So transposition minus 12 is negative 20. Divide by 5, so I get w squared equals negative 4. So take the square root of both sides. I'm going to work in colors still. The square root of both sides. And my solution then is W equals plus or minus the square root of -4. What's the square root of -4? What two numbers do I multiply together to get -4? There's no such numbers, at least not in the real numbers. If I multiply -4 times -4, this is an example using 3, negative and a negative is a positive. There's no number that I can, I can say this. There are no numbers that I can multiply together where one is negative and the other is also negative that's going to give me a -4. If I multiply together a -2 and a +2, that definitely equals -4, but squaring says it has to be the exact same number. These are two different numbers. So there's no number that I can multiply to give me a -4. So in this case, there's no solution, right? So this is erroneous, no solution. All right, I think one more example will probably do the trick. 25x squared equals 16. Okay, so first thing I want to do is just start solving. I want to get the variable by itself. So that means I have to divide through by 25. So I get x squared equals 16 divided by 25. Okay, that works. Take the square root of both sides. And I get, on the left-hand side, x equals square root property plus or minus the square root of 16 over 25. Square root property, or take the square root of a fraction, just means take the square root of the numerator. Sorry about that. Don't need the square root symbol anymore. The square root of the numerator is 4. And the square root of the denominator is 5. Luckily, the numerator and denominator are perfect squares, and so I could write it this way. If I couldn't, then I would have to go ahead and just leave the square root symbol there. But 4/5 is not my only answer. Remember, we're dealing with the square root property, and so you have to keep carrying that through. 4/5 and -4/5, and we write that as plus or minus 4/5, meaning there are two solutions to this equation. And if I were to check my answer, which at this stage of the game we're often still checking, 25 times 4/5 squared equals 16. So that's 25, and we don't know if that's true. We're checking our answer. Well, 4 squared is 16, and 5 squared is 25, equals 16. The 25s cancel. 16 equals 16. That's true. Check the other one. 25 times minus 4/5 squared equals 16, and we're not sure if that's a solution. So square in here first, so 25 times, well, a -1 and a -1. -1 squared is a +1, so the whole inside becomes positive. 4 squared is 16. 5 squared is 25. Exactly the same thing we had before. The 25s cancel, 16 equals 16. So two numbers or two solutions for a quadratic formula, or a quadratic equation. And when you use the shortcut, the square root property, in order to do it, in order to solve it, you have to allow for the plus or minus solution, both the positive and negative version. And remember, sometimes you're going to get negatives under the radical, and on the real numbers, in Algebra 2, you'll learn about complex or imaginary numbers, but in real numbers, there is no solution for the square root of a negative number.